Created using Powtoon.
And we're here. Thank you for joining us for Teaching Physical Sciences Grade 12. Today we're joined by Marissa. Hello, Marissa.
How are you, Helen? Nice to see you again since last week.
It's been a good 2 weeks, hasn't it?
Yes, it has.
Yes, 2 weeks of me. Who can complain?
They're quite hectic, huh?
Yes, and of course we're joined by Kieran behind the buttons. Dylan is not with us.
Hello.
Hello, Kieran. Welcome. He's got lots of exciting questions. I tried to prep him beforehand, but he wasn't that interested in chemical industry. So we'll have to talk a bit about chemical industry and get him interested, see if he has any questions, but I'm not holding out much hope. Of course, remember, you can win 110 Rand airtime if you talk to us using Twitter, the hashtag MEScience, or Facebook. Find the Facebook page, Digital Classroom South Africa, then find the post. Kieran will be watching both the Facebook post and the Twitter hashtag. And also, he is logged into the chat just below this screen. So if you scroll down just a little bit, you'll see there's a little box that says enter your nickname. You enter in a nickname, any nickname at all except for Digital Classroom, because that's what we're chatting under. And then Karen will talk to you over there. So send us some questions or some queries, or just pop in to say hello, and you could possibly win 110 Rands airtime. And of course, you can also win a phone or a tablet. And the way you do that is you send us your teaching resource. So watch out for the secret code that will appear at the bottom of your screen at some point during today. Write it down somewhere and send your teaching resource to competitions at digitalclassroom.co.za, and then we'll look at them and we'll choose a winner, and it'll be great fun, such fun. Okay, well, I think I did that in record time. Now, I know you were here last week, but just a brief refresher. Who are you and why are you important?
Well, I don't know why I'm important, but I work at WITS and I work with teachers. I teach chemistry education and chemistry. And I make new teachers as well as try and renew old ones.
That's so important, though, because we do get stuck in our ways. And so that's what you do.
Yes.
And your specific specialization is chemistry. That's
right. I call myself a chemical educationist.
I like that title, actually.
Not that I educate chemicals.
No, that would be quite difficult. Okay, Kieran, I have a favor to ask you.
Yes.
Can you please go to the Facebook posting we made a little earlier? And there's a quote that's on the Facebook posting.
Yes.
Can you read it out for us, please?
I'm going to get it.
Okay, while Kieran's getting that, I meant to tell you about this earlier, but I completely forgot up until this moment. I found a quote, and I just thought it was so beautiful about how we teach chemistry, or how others teach chemistry. I don't teach chemistry. I'm not very good like that. Kieran will find it. While he is finding it, I've been reading this book, Teach Like a Champion. And I think I've gotten to the difficult section of the book because the steps are now more difficult to summarize. You'll remember last week I said, just go and read the chapters so that you can get a general idea. This week I'm pretty much going to say the same thing. They labeled the step ratio. I don't know why, because in terms of mathematics, there's no ratio that's going on. They're just talking about the fact that you shouldn't only explain things once and expect a child to understand it. You should get them to participate in re-explaining it over and over, and the way you question them will also teach them. So it talks about the importance of good questioning techniques.
I've located the quote.
Oh, good. Karen is going to read it out. I hope your reading skills are good, Karen.
I hope so. Put it to the test.
Yes. Okay, you're going to read it.
Thus, for those of us who make us only brief study of chemistry, the benefits to be expected are indirect nature. Increased capacity for enjoyment, a livelier interest in the world in which we live, a more intelligent attitude towards the great questions of the day. These are the byproducts of well-balanced education, including chemistry in a proper relation of other studies.
Do you, Kat, I'm the kind of person who needs to read something in order to properly understand it. Were you able to gather meaning from that, or can I interpret it?
I got some of it, but I think an interpretation might be quite a good idea.
My apologies for my reading.
But the way I read it was that in order to get a balanced education, you have to include chemistry in that education, because it teaches us about life and why life happens. And it goes back to that sub-micro of the Johnston's triangle. It's not just, this is happening. It's, this is happening, but let's go more in depth and see what's really happening. And talks about chemistry igniting that want to see what's happening around you.
Well, one of the most important things that teachers need to think about when they're teaching a topic is, why is this important for students to know this? And there can be different reasons, different types of reasons why it's important. And I can classify them. The one type of reason is, because it's important in everyday life. And even the importance in everyday life can be divided into, it's important for me to know so I can wire a plug, or I can survive nicely in the world, and I can understand things so it helps me.
Yes.
Or it can be, so I know stuff so I can participate in public debate on issues.
Yes.
So those are the everyday life dimension. Then there's the dimension that I need to know this because I've got to learn something about it later on. And then there's the dimension that it's just interesting. So there are three different dimensions. Of course, there's the dimension because it's in the exam.
Yes.
And that one is quite pertinent for today, I think.
Yes. And, well, shall we go on to the first slide?
Yeah.
And Karen's going to pull it up. It says the importance of this topic. And I'm going to read out the first point. It says only 6 hours, so have to think about being strategic about the big ideas. Danger that the section could be left out, as it counts only 18 marks out of 150 for chemistry, which is just over 10% for chemistry. But in the bigger picture, it's just 5%. So there are very possibly some teachers who are leaving it out, aren't they?
Well, when you think about it, it's meant to take 6 hours of teaching in the classroom, according to CAPS.
So that's just over a week, roughly.
It's pretty much a week.
Yeah,
maybe a little bit more. And it's right at the end. This is the last thing that's going to be done. The next thing is revision. And really, why should I now start crowding them into this little section, which is so different from all the other sections, when I could be spending time revising something like organic chemistry, which counts 1/3 of the marks? Interestingly enough, when I was at school, the very last topic was organic chemistry, and they only spent about 5 minutes on it. And now it's a big chunk of grade 12.
That is interesting.
But I think that's the most important thing, is why should we teach this? If it's counting so little when there's big stuff for big stakes, and right now our minds, quite rightly, are concentrated on getting the kids to pass the exam.
Yeah.
I think that is an appropriate focus at this point.
I was surprised when you said that earlier, because usually And we have people come in and the concept, and it makes me really excited to hear people talking about how you get the concept of this and then you teach routine and things like that. But I think your argument holds merit in this case.
I'm one of those people.
Yes, I know.
But there comes a time when, there's a strategic need.
Yes.
That for the learners and for the teachers, because their track record also rests to a large extent on their success in getting kids through matric, and for the future of the learners.
Yeah.
This comes the time now where you can become quite mechanical and drilling, and really you just want any trick that's going to get them through the exam.
I liked your next point on the slide. Integrate. I liked all of your points on the slides, but this one I liked especially. Integrative, so you can think about using it to start revising, and then you've got a list of things that you can revise within the section. And I really like that way of teaching, where you take one section and you go, well, I can actually revise this over here, because it not only is it building on that little bit of knowledge, it's also it's doing revision, but within a context.
Well, that's the whole point about this topic, to be honest. It's part of an approach to science teaching which is called STS, which is Science, Technology, and Society, which usually means you start with the application and you use the application to teach the science.
Okay.
And this is probably the only place in our current curriculum where they actually do that. But it's such a good time, because what you're going to do is, by using the application to teach the science, you're using the application to revise the science. So in this section, you have opportunities to revise acids and bases.
Yes.
Because the products are acids and bases of most of the industrial processes that we're going to be talking about. Sulfuric acid, nitric acid, hydrochloric acid. And the other interesting thing is, although we are manufacturing acids and bases, the reactions that are used to get to the acids and bases are all redox reactions. So pointing out this contrast, that because we're trying to get sulfuric acid, ammonia, hydrochloric acid, nitric acid from various sources, the sources have to be from things we can find in the environment.
Yes.
I mean, like nitrogen in the air, and oxygen in the air, and sulfur in the ground.
Yeah.
They usually need to be oxidized or reduced to get them to what we want. So there's a redox story which allows us to revise redox reactions, which relates, of course, to electrochemistry, which is all about redox reactions. Mm-hmm. And the section that's just been done before this is electrochemistry. And one of the things in electrochemistry is the chloralkali industry.
Yes.
So I've unashamedly kind of imported that in here too, because it is really part of industrial process.
It builds on it nicely then, if it's last.
And then, of course, making ammonia is the Haber process. And the Haber process is a chemical equilibrium reaction.
Yeah.
So now we get an opportunity to revise chemical equilibrium in the best possible way, because the Haber process is a compromise. And it's a compromise that has to take care of equilibrium issues and rates of reaction issues, which I actually didn't mention there, which is another thing we can revise.
Oh.
And then finally, when I looked in the textbook, there were a whole lot of exercises on NPK in the soil and calculating them using moles.
Yes.
So that gives us an opportunity to revise moles as well.
Sure, so it really does revise a lot.
But then there's another little warning there, the last bullet.
Yes.
And this means that if I'm thinking this way, it means examiners could also think that way, and they might set an exam question which takes one of these industrial processes and tries to test some of the other sections in it as well.
That's a very big warning, actually. So say that again, just so that everyone can, just in case someone out there,
Well,
like
if
Karen,
I was the
dozed
examiner,
off. Yes.
if I was the examiner,
Yes.
I would think that's a very good way to set an exam question. And that is to ask one of these questions on industrial processes, but include in it one of these things that's been done before. And by the way, this idea of mine that it's a good revision thing, I thought I was so clever thinking
Well, I
that
think
up.
you're clever for thinking it up.
Yeah, but I was speaking to a teacher yesterday, and she also thought of it.
Well, it's good to know that we've got clever teachers as well. Let's take a look at the 5-point teaching strategy. I think Kieran's going to pull it up now. And the first one says industrial products are made from natural resources, and you've got in brackets bread from air.
So you want to know what I mean by bread from
Yes.
air? Okay.
It sounds like a great weight loss strategy.
No, I think it's a great weight gain strategy.
Oh dear. Okay.
Because what it's about is how do we get food?
Yes. Oh, okay.
So bread stands for food.
Yes.
And of course bread comes from wheat.
Mm.
And wheat is what we would grow to make bread. And how do we make the yield of wheat be better is we use fertilizer.
Yes.
And where do we get fertilizer from? But we have to start with the nitrogen in the air. We have to start by making ammonia.
Okay.
And if we're going to make ammonia, we need nitrogen from the air. 70 or more % of the air is nitrogen.
Yes.
So that's the most obvious place to get nitrogen. And then we have to react it with hydrogen to get ammonia. By the way, that is so difficult to do in industry. But plants with nitrogen-fixing bacteria can do it at room temperature and pressure.
The second point says the importance of different types of fertilizers and where they come from.
Well, the curriculum at this point is quite descriptive. It goes into a whole lot of different fertilizers and the elements that are in those fertilizers, which links to the second point. But what fertilizer would you use for the roots? What fertilizer would you use to enhance the function of the leaves? And so on. Now, I'm not a biologist, so I could talk utter nonsense at this point.
We do actually have a whole series on this, and where they explain all the fertilizers in detail, a mindset series. And I know a lot of teachers use it because they say the same thing. They don't garden, but it's good to have that kind of resource.
But the 3 key elements are in the third bullet point.
The third bullet point on the slide. Yes. The importance of NPK and their different ratios.
So, N, nitrogen, P, phosphorus, K, potassium.
Yes.
Now, that's interesting because a lot of learners, by the way, sometimes don't know that the symbol for potassium is K.
Where does it fall on the...
It's element
periodic table?
number 19.
That's strange, because we had to learn them the first 20 off by heart.
I have a mnemonic, actually, that allows you to remember it. I don't know if we can diverge.
Well, I don't know if we have enough time, but you should definitely send it to me so I can put it on the blog.
Okay, I made it up myself.
Oh, even better.
But the nice thing about this is you've got phosphorus, which isn't pronounced phosphorus, but it starts with a P. And then you've got potassium, which starts with a K.
Yes.
And the reason it's K is it stands for kalium, which is the Latin for phosphorus. Now I'm getting confused. For potassium.
Okay.
And the thing is, the reason why it's so important to know these elements is even if you were in China or you were in Russia and they were even writing in a different way, they would still write the symbols like this. So if I picked up an article about chemistry which was written in Chinese, I would still be able to understand the equations and I would still be able to understand the symbols of the elements.
So it's like maths in that way?
Yes.
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 Okay, the fourth point says industrial production of fertilizers.
Sorry, I just want to take you back to the third point.
Please take me back.
We got so tied up with the symbols that I forgot to emphasize that the different ratios
Yes.
of N to P to K are the key things in the different types of fertilizer, which is in the second bullet.
Yeah.
So if you put a lot of N, it's one. If you put one, and so if you're a farmer, you need to go into the shop where you're buying the fertilizer. You need to know which one you're buying, otherwise your fertilizer is going to do the wrong thing. And fertilizer now costs a lot of money. I believe it's like 500 rand per bag, 100 kilo bag. It's or 50 kilo bag. It's quite very expensive, so you wouldn't want to buy the wrong one.
Yeah.
Okay, now we can move to the
Point 4 says industrial production of fertilizers strategically linked to their sources and processes. Focus on reaction types.
Well, that's more or less relating to what I was talking about in the importance of the topic.
Yes.
So you've got sources and you've got processes. So the sources is where do the fertilizers come from? They come from the air. They come from nitrogen. They come from hydrogen. And phosphorus comes from the ground. So these elements are key. Where do they come from? So that's the source. The processes is what are the chemical reactions that need to be carried out. What kind of chemical reactions are they? And relating even to the grade 11 stuff we were talking about last week, are they endothermic or exothermic? And do they need an activation energy? And how fast are they?
Yes.
Because we did rates of reaction also in grade 12 as well. So that's what I was talking about. Now we can move
It really is a good section to bring all of these into.
Yes, I mean, it really brings everything back. If you're clever about how you teach it, you can bring everything back.
Okay, the last point says fertilizers and the environment.
Well, if you look at the textbooks, you'll see there's quite a big section on things like eutrophication, and fertilizers can do good and bad.
Yes.
So too much nitrate in the soil can seep into the water table and cause excess nitrates in dams and things like that, leading to what they call algae bloom and eutrophication. And the problem with nitrates is all nitrates are soluble in water.
Yeah.
So it's very hard to get them out. If it was maybe a chloride or a sulfate, I could add something to precipitate it out.
Yeah.
But in the case of nitrates, there's no nitrate that's not soluble.
Yeah.
So it's very difficult to get nitrates out of the water. And for example, at Hartbeespoort Dam, there was a big problem about water hyacinth growing.
Yes.
It's also in Cape Town, if I'm not mistaken.
Yes, I think so, yeah, in the fresh water.
Yes, I remember doing a project in grade 4 about it.
Oh, wow. Some people can remember all the way back to grade 4.
Some of us are younger than others. Oh, well, it's an important, I'm sure it's important. Do you think it would be asked in examinations?
Well, it's in the curriculum, and if I'm setting my 16-mark question, how many marks did I say was going?
I think you said 18.
If I'm setting my 18-mark question on, I might very well ask a question on the environmental impact of fertilizers.
That would be quite easy to remember, I think.
It would be easy marks. So that's another reason it's not difficult to understand. And it would be easy to teach. Of course, this is the first year we've got this new curriculum being examined.
Yes, so
it's unfamiliar territory, but not that unfamiliar. I think if we look back at some of the NCS papers, there'd be quite a lot of questions about fertilizers that you could revise with the students.
Yes.
But, I mean, some teachers might think I would get more gain spending the time on stuff they've done and bringing it back. But I'm saying that might be easy marks.
I think it might be as well. Okay, we're going to look at the slide with the 3 pressure points now. The first one says, look for innovative ways of teaching. This topic can be thought of as descriptive and taught in a rote manner. And of course, rote manner, you mean rote learning.
That's right.
Yes.
It's a bit sort of geography-like, if I can insult geography. Because when I was at school, you just had to learn geography.
Yes.
Maybe it's improved these days.
I don't know. I'm not very good with geography.
Geography is quite good.
Okay, Karen has...
we have an endorsement.
Yes.
But the trouble is, with industrial processes, I can just teach it step by step as a series of facts. This is the process for making sulfuric acid. First we do this, then we do this, then we do this. Here are the equations, go and learn it. And that's really boring.
Yes. And it's always more difficult to learn boring things than interesting things.
Some kids would be happy with boring because it's not too demanding. Some of the more interesting ways of teaching are more demanding on both teacher and learner.
Yes.
And I'll be going through some more exciting and different ways. Of course, one of them is just totally inappropriate at this time of the year. And that is, to me, the most obvious way to teach this is to go and visit a factory.
Yeah.
Where they process, for example, the chloralkali industry. If you're a Mamelodi Sundowns fan, you could take two places in at the same time. Because it's at Kleurkorp near Kempton Park,
yes.
if you're in Gauteng, which is where Mamelodi Sundowns headquarters are. There's a little piece of useless knowledge.
I'm sure the matrics would appreciate a trip like that, but the timing is very bad.
The timing is shocking.
Yeah.
But I think that's one of the best ways. But one of the things, if I can make some general recommendations, if you do one with one of the other classes, is don't send the English teacher, which often happens with class field trips,
yes,
rather than the science teacher. And the other thing is prepare the learners before they go.
That's so important. You can't just take them to a place and expect them to learn while they're there. They need to recognize what's happening.
Absolutely. And give them something specific to do while they're there.
Yes.
And when they come back, debrief.
You know, there's some really exciting things that you can do with getting them to do things while they're on school trips, which really build their learning so much.
I've got a colleague who actually researches how much learners learn. And he's found that in those short 3 hours, they learn more than you think by going to these places. But, of course, that's off the agenda right now because this is a very bad time to think about doing field trips. But there are other innovative ways of teaching in class which can also be fun and can also be interesting, and we'll look at some of those.
Your second point says link to past work and then, of course, see the slide on importance. And I think we've spoken about that enough.
Quite extensively.
So let's go to the third point, which says applications are primary. One of the few sections concentrating on the applications of science to everyday life. That's a bit sad, actually, that in 3 years we learn all of this stuff, but the parts where we actually apply them or can see them in everyday life are quite minimal.
Well, that's why I yearn for the NCS curriculum, which teachers were just managing to get on top of when they pulled the rug from under us, is because that was meant to be an STS curriculum. There was something called Learning Outcome Number 3, which was very much about science and everyday life. And the promise of examining Learning Outcome 3 was not really fulfilled in terms of the balance in the science paper.
Okay.
But that's really talks to my STS point that I made a little earlier.
Okay. Okay, now we've got a series of good ideas here, or you put together a series of good ideas here, and I know we're going to talk about some of these a bit more in further slides as well. The first one says concept maps are very popular. Can you explain to us what you mean by a concept map?
Well, I think even in quite a few of the textbooks, they have either flow diagrams, which show how one idea leads to another, or what I call concept maps. In fact, the examples I'm going to show you are not strictly concept maps, because concept maps are supposed to have words in boxes, and maybe I will, it'll be something like chlorine, I might put here.
Okay, so on the board, Karen.
And then I'll go is made from, and then I might put salt.
Okay.
So that's an example of a part of a concept map. So they can be done in different ways, but the best way is to make learners construct their own concept maps, possibly from reading a piece of text. So that teaches them how to decode text.
Yes.
So maybe you get the textbook out, you let them look at the paragraph and say, use this paragraph to make a concept map.
I think it's really valuable for them. I'm actually surprised that they wouldn't have done it in a lower grade already.
They might have done some before. I think in biology they're very popular, the concept maps.
Yes.
But it is another way of trying to get them to understand things a bit better. And but when the linking words are left off, then maybe they could be described as flow diagrams or something like that.
Okay. Okay, the next point says Science, Technology, Society, which is the STS approaches. And
we talked about that, starting with the application and using it to teach the science.
Yes.
So I start with the production of ammonia. And the man who first invented the industrial process to get nitrogen and hydrogen from ammonia from nitrogen and hydrogen. I don't know if this is a good time to talk about that.
We can, but I want to add one thing quickly to this, and this is something I have an internal struggle about all the time, and that is I often wonder if we should be teaching from this STS purely, or we should be doing skills first and then bring it all together with an STS once they've got the tools to cope with the application in real life. Or should we talk about the real life and say, well, actually, the real life, we've got reactions happening there, we've got the NPK or whatever else, and link it all back. And I'm always in two minds about it.
Well, there's certainly a lot of evidence to show that skills taught in isolation can never be learned. For example, if I send you on a computer course and you never use that stuff immediately, you won't remember any of it.
Yes.
But if the skill is done in a context, then you see how it operates in a context, and it gives you a way of learning that skill much more easily than if you just learn it in isolation.
That analogy really makes a lot of sense to me because, I could learn chemistry and I'd be able to do everything routine, but I'm not able to apply it.
But the idea of the science, there becomes a need to know.
Yes.
What the STS creates is a need to know.
Yes.
And there's quite a lot of debate as far as the STS is concerned about whether learners learn more through the STS approach. And actually the findings are they don't learn anymore, but their attitudes to science improve.
I was about to say that the value of the knowledge becomes
more. They learn about the same.
Yes, but the intrinsic value to them. Okay, you were going to go on to the next thing.
Well, I was going to say, while we're talking about science, technology, and society, maybe we can say a little bit about Fritz Haber.
That's a fantastic idea. I'm going to go down to the slide. It's still going. Bread from Air, the story of Fritz Haber.
Now, Fritz Haber is a very interesting character because he was a Jew living in Germany just around before the First World War, which, by the way, the start of the First World War had its 100th anniversary last month.
Oh, yes.
So more than 100 years ago, he lived in Germany. And Germany went to war with England and other countries. And the problem was that they wanted to make explosives. Now, of course, one can have a debate about whether scientists should be involved in things like making explosives for destruction. And that's incidentally why we have a Nobel Peace Prize, because Nobel was so devastated by what was done with his invention, which was dynamite, that he instituted these prizes for peaceful purposes.
Yes.
But Haber wasn't that worried about his inventions being used for war purposes. And nitrates are needed to make explosives, as well as for fertilizer.
Yes.
So the only place in the world in those days where you could get nitrates was from South America. And the boats couldn't get to South America because there was a war going on and they'd get stopped by submarines and things like that. So the pressure to find a way to make ammonia from nitrogen and hydrogen became even more intense. And as I said earlier, nitrifying bacteria can do it very easily, not to get ammonia, but to get nitrates.
Yes.
And so it was a matter of finding the right conditions for the reaction. And it's an equilibrium reaction. So that's why I said you're coming back and you're revising chemical equilibrium.
Yes.
Because there's Le Chatelier's principle
Yes.
and all the things that you had to learn in chemical equilibrium. Finding the right pressure, but then also finding the right temperature. And the problem with the Haber reaction is it needs to be done at high pressure, but it needs to be done at low temperature for the best equilibrium yield. But the problem is if the temperature is too low, it's too slow. So there's a whole compromise involved in having the temperature just at a kind of medium level, and finding a good catalyst was another part of it too.
Okay.
So he managed, and so they managed to produce it, and that was a great discovery and helped Germany make explosives in the Second World War.
Okay.
So just a little bit of social issues around Haber. As I said, he was a Jew.
Yes.
And he was a very patriotic German. So he believed not only was he a Jew, but he was a German as well. And he won the Nobel Prize in 1918 for his discoveries, which is quite ironic because he also invented these poisonous gases that were used in the First World War.
Oh, my word.
And he... those poisonous gases were eventually used in the gas chambers by the Nazis to kill Jews. So that was a very interesting thing. And his wife, because she had an argument with him about it, she committed suicide.
Oh.
And then his son was also ashamed of him. And eventually he was thrown out of Germany because he was Jewish when the Nazis came to power. So the whole interaction between science and society is quite strong in the story of Fritz Haber.
So, he's a very interesting man. We're going to go back to the good ideas. And you said websites, Shuttleworth, which is the Siavula website, and the CIEC, which I'm not familiar with.
Okay. The Shuttleworth one is just a 2-pager, and there's a link in the Shuttleworth book that takes you there.
Okay.
So you actually don't have to remember that. If you've got the electronic version of the Shuttle Siavula books, you can get that. But the CIEC is the Chemical Industry Education Centre, and it is based in York in the UK.
Okay.
And they have wonderful stuff, wonderful resources on chemical industry. And their website is called Essential Chemical Industry.
So we've got the link, and this will be in the blog, so people can go through and click and see all the good ideas.
There are other websites, but I just picked on those two. And actually, one has to be careful with the internet because there's a lot of junk out there as well.
Oh, my favorite is when people quote Facebook postings at me and then say, well, it must be true, it's on Facebook. Oh, no, man. Have some intelligence about what you're viewing on the internet. Be discerning.
Well,
Choose
my
something that
advice
works.
actually about if you look up something, even Wikipedia is not that reliable.
Yes.
So look up 3 places.
Yes.
And if they all agree with each other, you're sort of on the road to something. The Royal Society of Chemistry is good. The American Chemical Society is good.
Okay.
With education resources as well.
Well, thank you for those. Then you've got the point about debates.
Okay. If we move down now...
to the end.
Yeah. I don't know if this one is included.
An example of a debate.
If this one is included, it'll be in the blogs otherwise.
Yes, and Karen's about to put it up on screen as well. For some reason, the capture is one slide behind. I don't know what's happening. So we'll go back to the shot of our pretty faces. And we'll have to read out the example of the debate until it comes up on Karen's screen. The first one says the first point says the City Council wishes to pass plans to build a nitric acid production plant in your town. The Mayor has called for a debate in the town hall to discuss the issue. You have found the following pamphlet from the internet, and then we click the link and it'll pop up. Yes, you want to add to this at that point?
Well, this is what you give the learners.
Okay.
You give the learners a piece of paper, or you write it on the board, or you write it on a big flip chart or something like that. So that's the scenario.
Okay.
But you need resources that go with the scenario, something that's got the actual information in it.
Okay.
Because the debate has to be about a scientific issue.
Yes.
And so what that pamphlet would do is it's basically just a booklet that talks about the production of nitric acid, which they've been learning about. But it might also mention some problems in the process that you've got to watch out for, drawbacks. And so there's going to be a debate. Now, in the town hall, of course, you're going to have people who are interested in jobs. You're going to have people who are interested in the environment. And sometimes you can plant those people by making specific roles for particular learners to take part in the debate. And you can have the bosses who want to make the money.
Yes.
You can have the people who own the land where they're going to put the factory.
You could have a real field day with this. You could actually allocate real trade unions to it and real bosses people. And
you can have the EFF there. You can have...
Yes.
And so what a good idea is to let the learners read the pamphlet overnight.
Okay.
So that they've had a look at it before. And then you will give them a bit of time to prepare. And then your key thing is to find a good chair. So you find a learner in the class that you reckon will manage to chair the meeting.
Okay.
Now, the most interesting thing is you could have a vote at the end. And what's so spectacular about this is there's no one right answer.
I was just about to say they're going to be scared to choose the right. They want to choose the right answer because it's
no.
fast,
The nice thing about social issues is it's more than just the science that's going to decide what the outcome is.
That's a fantastic idea.
So while you might feel a bit pressured now, it might be a nice way of letting off steam in the middle of this end of the year process.
Yes.
And the kids really enjoy them.
Yes.
I can tell you that.
I think it's a wonderful idea. Okay, I'm going to go back up to the slide on good ideas. We're almost there. The last one says social impact of science, e.g. Fritz Haber.
Which we've talked about.
Yes.
So I've got some more examples of resources that you could use for teaching the chemical industry.
Okay, and we've got a slide up right now. That's that one, yes, which says spot the salt and its products.
Okay, Helen, have studied this picture.
Yes.
I know it looks a bit like somebody who's on holiday somewhere to see who's not here today.
Rub salt in the wound, Marissa. Yeah. Okay, so you would get them to spot all the salt products
Can
there.
you tell me where do you see salt in that?
In the water, Marissa. In the water.
That's a good one. You
Yes.
can go to the top of the class for that.
Thank you very much.
Anywhere else?
Well, I'm assuming that everything is there will have some kind of salt within it. I mean,
specific. I want you to home in on.
okay, the
Let's
cooler
just-
box is plastic, so it isn't salt used to make plastic?
Well, salt is used to make chlorine, and chlorine is used to make plastic. So yes, you're right.
And I know this because we looked at the flow or the diagram earlier, so I feel a bit
I
better.
mean, there's stacks of stuff in that picture made of plastic.
Yes, so everything that's made of plastic.
The umbrellas, the sunglasses, the swimming costumes, the seat.
Yes,
It depends what those towels are also made of,
yes.
if they're synthetic or if they are cotton.
And then
But I can see some more salt, unprocessed salt. that you
on the food,
on the food. And where else?
in the sand?
Yes, possibly.
Okay,
But you haven't guessed what's in the teacher's head yet.
No, I haven't. I can see that. Karen's just pointed to his underarm. I think he's trying to tell us something.
I think he got what's in the teacher's head.
Okay, so your body is producing salt. Is that?
You're sweating.
Okay. I don't sweat, I glow.
Well, whether you glow or sweat, if
Yes.
you're out in the sun by the beach, I promise you're probably sweating.
We'll have to ask someone who's been to the beach recently. Any Cape Townians or Durbanites out there want to drop us a line? Do that.
It's a bit cold at the moment, but...
That's a good... Yes, it is a bit cold. That is a good picture to use to emphasize.
Yes, well, I mean, if you're a good teacher, you can go searching the internet for nice pictures to use as resources like this. You can always put the word image after something that you're looking for.
Yes.
One of the things I was really looking for, which I didn't find a good one, was I was looking for a football game.
Oh.
With fans in the stands, with hampers, and also, maybe lazing in the sun and so on. So if anybody out there finds one, they can send it in as a teaching resource.
Yeah. Do that and win a phone or a tablet. Now, for some reason, the thing isn't updating. There we go. Now, Karen's going to pull up Is this called a flowchart? Yes.
This is a sort of flowchart cum concept map.
Okay.
Because it's got stuff along it, but the things it's got are the equations for... so you can see alongside there and there are all the equations. And this is all about the chloralkali process. Now, it's a bit naughty of me. I've smuggled it into this section because it actually belongs with the electrochemistry section, which is before this.
But it's a good building block.
Yeah.
It's good scaffolding, as we like to say.
And this is done by John McBride, our very own John McBride.
Yes, he's a good man, that John.
And he actually has color-coded the acids blue. I don't know why blue, because acids go red with litmus.
Yes.
I'll speak to him about that afterwards.
I think so.
And then the sodium hydroxide is red, and the products are all yellow. But right at the top here, we've got salt, which we had in the previous picture. So salt, which we can get from the sea, it's like one of the most important resources that we get from the environment. From salt we can make margarine, we can make plastic, we can make soap. And that all starts by breaking the salt up using an electrolytic cell into sodium and chlorine. I'm sorry, into hydrogen and chlorine. You have to melt the salt to make it into sodium and chlorine. So this is called brine, which is a concentrated solution of salt.
Okay.
And out of it we get hydrogen gas.
Yes.
At the cathode and chlorine at the anode.
Yes.
And hydrogen plus chlorine will give us hydrochloric acid.
Also a useful substance.
Well, it's one of them. It's pool acid.
Yes.
And just using the chlorine and reacting it with different things like ethene, hydrocarbons, we can make plastics. Hydrogen, hydrogenating fats and oils, we can get margarine.
Okay.
So this is a very nice concept map.
And you would use this in your teaching to show how salt becomes a whole lot of other things.
Exactly. Or you could get the learners to make one.
Well, shall we go on to ones that have been made by other people?
These two maps were made by two teachers.
Okay, so this one and the next one.
Yes. So this is Mr. Sibia.
Yes.
And he's given me permission to use it today.
Unfortunately, Karen's side is not updating, so we're going to go back down to the other one. Are we able to talk about this one?
Yes, this is Mr. Ndimande.
Yes.
And Mr. Ndimande has also given me permission.
Well, thank you to both of you.
And they're both physical science teachers in Gauteng.
Okay.
And the interesting thing is I asked them if they would draw for me a concept map that showed how you get nitric acid, sulfuric acid, and possibly ammonia from natural resources, and also to say what reactions are being used,
Yes.
and to say if they were acid-base or redox reactions.
Okay, and they both came up with things that look different to each other.
They look different to each other, but they've got different ways of showing the same information. And actually, they summarize all that's got to be learned about the two processes, but they are very well integrated together.
Now, would you get your students to do this, or would you give them a flowchart and ask them to...
You could do it both ways. It depends. Okay. I mean, if you look at this one of Mr. Sabia's, you can see he starts here with iron sulfide.
Yes.
Now, sometimes you can start the contact process, as it's called, with pure sulfur. But it's only countries like America where they will mine sulfur pure. Here in South Africa, we've mostly got to use sulfides.
Okay.
And it's called roasting. When you roast that sulfide with oxygen, you get sulfur dioxide.
Okay.
You react that sulfur dioxide with some more oxygen, you get sulfur trioxide. When you add water to sulfur trioxide, you get sulfuric acid. And the interesting thing is, in the industry, actually, we have to use sulfuric acid because this is very exothermic. So there's your endothermic and exothermic reactions being discussed again. And then here on the side, we've got calcium phosphate. So we can see how sulfuric acid becomes very important in the making of phosphates.
Yes.
Which are vital for fertilizers. So that's just one arm of the map. But when you go through the resources, you can look at all the different pathways.
Yes.
The other interesting thing is both these flowcharts are good, but they're different.
Yes.
Which tells you that actually there isn't one right way of doing these things.
It's a really good section, apparently, to show you that kind of thing.
That's right.
We don't have very much time left, and I know you want to talk about fertilizers as well. The impact of fertilizers more.
Yes, I found it fascinating. I mean, when did they first find out that fertilizers were so helpful?
Well, it's like who cooked the first potato and found out that it would be tasty once you boiled it. Those questions.
Well, there you could have had a fire, and then there happened to be some potatoes.
That's right.
Well,
just belittle my example.
Maybe somebody peed on the plant. Because there's nitrogen and urea in that as well.
Well, maybe.
But, I mean, people certainly knew that if you use decomposed, like cow dung and things like that,
yes,
that was good for the soil. And that is natural fertilizer. So there is a section on natural fertilizer. But synthetic fertilizers, they started discovering them in the 19th century. And this slide that I'm looking at now comes from the essential chemical industry website.
So Karen's going to pull it up quickly so that everyone can see that we do have the slide, and you're welcome to read it on the blog.
Yes, we're not going to read all the details there now, but just to say that is an experimental field. And what they found is you get huge improvements in the yield of crops.
Yes.
By using fertilizer. That's why subsistence farmers are at such a disadvantage to industrial farmers, because the industrial farmers, by using fertilizer, can make huge improvements to their yields. But of course, there is something called the law of diminishing returns.
And what is that?
It means that the first time you use it, you get a hey wow effect.
Yes. And
you get a huge, massive increase in your yield. And the next time, the improvement is less, and the next time, the improvement is less, until eventually the improvement is not very big at all.
Why is that?
I think because there comes a point where it's hard to make a big difference. I can't answer that question very directly, but
Okay.
I mean, it's a bit like if I train you to run 100 meters.
Yes.
And you've never run 100 meters before, I can probably halve your time in the first couple of weeks training. But then it gets harder and harder to get improvements of the same magnitude.
Okay, that analogy makes a lot of sense to me. Okay, we need to start ending off. Is there anything more you want to mention before?
Yes, there's something about the environment.
Oh, yes.
I had a few slides, but...
fertilizer, is it this slide?
Yes, the one on fertilizers. Just to say, you need to handle that undesirable effects of fertilizers as well as the pluses. And you'll find that there's some people who believe in green and organic gardening, and this is for this very reason, that nitrogen-rich soils favor fast-growing species, so the slower-growing species don't survive that well. And what I mentioned earlier, what we call eutrophication, which is due to the fact that nitrates are very soluble in water. So, as I said, this is easy marks, because unless they ask you some real STS question, it should be fairly easy to answer.
I have found this fascinating. This topic is fascinating, and the way we teach it, or it should be taught, also looks like a lot of fun. Thank you very much for joining us.
It's a pleasure.
Thank you, Karen, for all of your input and for finding the right slides at the right time.
And the right spot at the right time.
Yes. Join us again next week. We'll be talking about grade 10, and I forget the topic, but it will be interesting because Temba is coming in and he's a fantastic man to talk to. So, it's instantaneous speed and motion and equations of you know, that thing. Yes, so join us again next week, and remember to send us your teaching resources because you can win a phone or a tablet, and we'll see you soon. Goodbye.